This is the first in the videos that I've labelled Funway into SME. Today we're going to be going over the circuit description of the LED flasher, which has been taken from the Funway into Electronics 2, and basically convert it to a surface mount project, plus add a simple soft on-off switch to the circuit and show it in operation. So basically, let's go over to the circuit description. So let's start with soft off-on circuit. So this is a new section I've added, improving on the original design, which required a switch widened series 9-volt source. So this part of the circuit here, all this here. So when a battery is put into the battery clip, and obviously, so to make sure the circuit doesn't power up, there's R9 here, prevents power going to the circuit and causing it to start receiving power from the battery before the switch has been pressed. So we don't want this turning on when the battery is put in. So when this switch here is pressed, this causes C3 here to charge up to the supply, which causes the circuit ground here to drop to 0 volts, which causes the bias on Q4 here to turn on. So this then starts to conduct and allow the circuit ground, i.e. the flasher, get a connection to ground and connect it to the battery and start to operate. In turn, of course, pressing, this causes Q3 to conduct, and Q3 maintains the biasing for Q4 to maintain the circuit being active. Of course, when the button is pressed, the button causes the biasing to be removed from Q4, which also causes the Q3 to no longer conduct, which disconnects power from the circuit and effectively turns it off. Now this N-channel MOSFET here can handle up to 30 volts, but we're only dealing here with 3. This circuit can be expanded up to 12 volts, but you would have to change the dropping resistors here, and you could put more resistors in series if need be. So with these LEDs, there is a 2-volt drop across them. That could be changed so you can have more LEDs in series if you go to a higher voltage. The transistors will be more than capable of handling the current load, no issue there. And of course, depending on the flashing frequency, you just basically change the capacitors here. The 100 microfarad capacitors give a relatively on-off type flash. You'll see in the video. So basically, the frequency of oscillation is set by the RC pair of C1R2 and R3C2 to cause the LEDs to flash in oscillation. So basically, if you want to change the frequency of the circuit, you go with the constant of 0.69 times by R times by C, with R in ohms and C in farads. And you work it out for each side of the flasher and add them together. That'll be the total time taken, but the individual times will tell you how long that side of the LED will stay on in the oscillating cycle. You could slow it down by putting in a higher value, so going all the way up to, say, a 220 microfarad capacitor, or even a 400 microfarad capacitor if it's available in a 1210 package, or you can put it as low as 47 microfarads, which will speed it up fairly quickly. Alright, anyway, let's go over to the soldering bench and solder the circuit up, and then we'll see it in action. Okay, so as we've just got over the circuitry, what we'll solder on first is we'll go onto the back and solder on the battery holder. Now, unfortunately I forgot to put on there which side the positive goes on, so just be aware, this edge piece here, that's the positive, and where it shows this leg here, that's the positive. So battery holder goes on like so, easy as that. So one thing as well when doing surface mount electronics, now the nib I've got on mine is a little bit too, it's cooled down, is a little bit too blunt. We need a fine tip, so I ordered some fine tips for this, specifically for doing surface mount. So you take it off like so. Well,
You basically change it to a fine tip. Now I got two types of fine tip. Now unfortunately one of the ones I purchased is only a little bit more finer, which will probably do the trick, but in this case, because we are doing some fine legs, I'm not going to use this fine tip. I'm going to actually use this one. This comes to almost like a needle point. Now, unfortunately, I would normally use my Dick Smith's temp soldering iron, but unfortunately it died a few weeks back. I had to get a new soldering iron, so I got a usual cheapie from eBay. Switch the soldering iron on. Now we want to set the iron to about 345. You don't want it too hot. So I'll just wait for this to heat up and we'll get these legs soldered on. Now I use leaded solder, so 60-40 lead. Sometimes with surface mount Eutectic is probably the better solder to use, but it's not easy to be able to find these days. But if you can find Eutectic solder is a much better solder to use. Alright, we are up to temperature. I have a little bit too much solder there, so we'll wick a bit of that away with some solder wick. That's the beauty of surface mount electronics. If you use too much when you're hand soldering, you can always wick it away. Now I will admit, the amount of heat I'm applying here is not a good thing. You have to be careful when doing some soldering with more sensitive components. Have the wider tip when soldering this battery clip on. But everything's all good. It's all nicely soldered, all seated properly. Let's continue on with the assembly of the actual LED flasher. As you can see, we've got the variety of components. What we'll go with first is we'll do the switch. Alrighty, so now, like with every surface mount component, we're most likely going to be needing tweezers. Now, if I've ordered the correct switch component, that should make up without any issues. There we go. That switch will allow me to turn it wrong footprint. Ordered the wrong switch. Shoot. Alright, I'll have to go to electronics later and hopefully buy a equivalent switch. Alright, so we'll start with the bottom here. R1, C1, C2 and R4. Now they form part of the LED flashing circuit. So let's get these components. So R1 is a 15 ohm resistor, so is R4. There we go, 15 ohm. Really? So the tweezers, you pull back the tape, flip the resistors on there. So here comes the interesting part. So on one side of the pad, this is R1 and R4 we're dealing with, you apply a bit of solder. Now to make it easier for me, being that I'm right-handed, I'm going to rotate this in the holder because basically, sorry, rephrase that, blow around. Yeah, no, this way around. So I'll be holding the tweezers in my left hand and soldering on in my right hand. So with the tweezers, I grab and align, and then I heat up the solder with the iron and move the chip into the solder, like so. So normally you would try and get component values showing the same way, but I'm a bit lazy. And then what we do is we come in on the other side with a soldering iron, a little bit of solder, and just touch. Now, hand soldering surface mount isn't as neat as using a reflow oven or a reflow board heater, but it means basically you can assemble your own boards. Just like so. Easy like that. One lot of components down, ready to go. So we'll do those caps next, C1 and C2. So a 2.2 microfarad and a 10 microfarad capacitor. Now one thing as well, when you get stuff like this, pays to put it back in the bags they came in, otherwise you will actually forget what the components are. So these are 15 ohm resistors, so I'll put them back in their bag. So this is the 2.2 ohm microfarad cap. Now in this case, I won't have too many issues because this one is physically a different size to the 10 microfarad, but normally you don't get that luxury. Now the caps are going to be fairly easy to solder up when it comes to them, and the LEDs. Where it's going to get difficult is with the transistors. We're dealing with smaller legs, but with the fine tip but with the fine tip soldering iron, it should be relatively easy to solder. Now with a lot of these projects, I have chosen the bigger size in the SMD because they're much easier to hand solder than what the smaller stuff is. So, same as before. A little bit of solder on the pad. And with your tweezers, bring your soldering iron up. Not the solder. Probably need a little bit more solder on the pad. Yeah, it's been a few years since I've done hand soldering of stuff. And then solder the other side. Alright, I'm gonna basically bug out for the moment. I'm gonna finish soldering up this board and then I'll see you in the next one. Now, I might show some highlights of some of the components, so I might show a bit how we do the transistors, and also with a very tightly packed board like this, you can see some of the ways of how I solder basically in the next montage. See you after the complete soldering up. There won't be a switch on. I've got to go and pick up one. Now, one thing with these LEDs, along there is an arrow that points towards the cathode, and then obviously it goes in that way up. You see this bar here? That's the direction the arrow's got to point. So again with this LED, arrow's that way, so I have to turn it around that way. So we've got most of the main components soldered in for the LED flasher, except for the battery saving circuit, or the soft on off. But we have two transistors to put in. These two transistors are BC848. The through-hole component version would be a BC548. This helps with, this is what allows the circuit to effectively flash. So let me show you how we will go about soldering in these transistors. Now, as components get on the board, it starts to become more difficult to solder stuff. Generally speaking, you try to solder the bigger stuff. You try to solder the smaller stuff first, and then generally go on to the bigger stuff. But I'm also showing that sometimes it pays to go from left to right, or vice versa, to be able to get components in. So I'm going to rotate this board around, so I can get to these single legs here first. Those single legs are the leg we're going to hand solder with the tweezers, and then the others will solder by with it already on the board. So there's a process to soldering things on. Right, these were some transistors I bought for another project, but they're the same style and same type. Come on, out you come. There we go. Do not handle components like this. Not a good thing to, not a good practice. Okay. So here it becomes a bit more challenging. Just gotta get some solder onto these pads here. Like so. So for this one. Clean my iron. Do as before, I will move that single leg into the solder. So get your soldering iron ready, grip the sides of the transistor, melt the solder. Don't get stuck on the iron. That's the second. It has been a while since I've soldered transistors. You've got to learn to be good with both hands, that's for sure. And there you go, there's one transistor in place. Now with the other one. Might want to readjust that. Yeah, it didn't solder. Now I got it the right way up. Yes, I do. Not sufficient solder on the pad. I want a little touch more on there. One thing about SMD soldering is you've got to have a lot of patience. Man, especially when that happens. Excuse me. I need that in position. Okay, let's try this again. So there we go. Now, once this is all soldered, if I hadn't soldered the battery clasp on the back, I could have used my board heater. What that would have done, it would have heated up the board, got everything to flow again. Now, with the battery clasp on there, I can't do that. Alright, there it's all done. Now I do need to go and get the tack switch, but I'm now going to show you how using hot air I can actually clean this board up. And then of course I'll do another one where I'll show you using the board heater, and that's if you have them. But this is more or less to show you can hand solder simple circuits like this. So I just got to wait for this to heat up. And then slowly but gently heat the board up, heat the board and components nearby up. And you'll see things will start to move. Now, the reason it doesn't blow away is because surface tension helps hold everything in place. Sometimes a hanging flux handy helps as well. See? So there it's gone molten. Chip resistor is straightened up. And with that one. See? so the tension's pointing straight. Yep, that one's kind of straightened up. There we go. Put some heat over the transistor legs. As you can see. A little bit of hot air. Things straighten up. The reason I don't go any bigger than 1206 is because you can still heat the entire component and its solder joints with a hot air workstation. And get everything nicely soldered. And there we go. Well, that transistor needs a little help. Not perfect, but then again it is hand soldered. But it shows just finishing it with a little bit of hot air works a treat. You'll also notice that there are a few joints that have a bit too much solder. That can have tendency with hand soldering, but like I said before, solder wick is your friend, like so. Soaks up that excess solder like that. If you want to lose it, there's a little bit of this there. Now be careful after using the hot air, it'll be very hot. So there we go, that's the circuit all soldered. Now I'm going to pop this into the cleaner, and I've got to go down to the supplier and get a switch to go there. I'll see you then.
A few moments later.
Okay, so I'm now back. I've got the tack switch, and let's get it soldered on. So these were the tack switches I actually designed it for. And of course, I forgot to order the same ones off of element 14, so you can see it goes just there. So I'll put that to one side for the moment. Let's get some solder on one of those legs. Just go wait for the soldering iron to come back up to temperature. Just some solder on that leg there. Switch it on. And heat it up. And there we go. The tack switch has been soldered on. So, grab the battery. Okay. Time to drop the battery in. Alright. Now, when I push that button, that's supposed to be working. Alright, something's not right. Okay, that's 3 volts there. Let's go around testing some voltages. First thing to see if there's voltage on this circuit. Q3 there. So I need to pick up ground from somewhere. So R8 has a ground, 3 volts is there, so okay, I'll bring 3 volts there. Let's go to continuity. They're common. They're common. Not common. So that side goes to that side of the transistor. That's correct. And the other side, basically it comes from that side of those resistors there. So those two there. Yeah, that's correct. Let's check for voltages. Okay, so should be 3 volts. from one side of the PMP in relation to ground. Okay. So nothing there. That circuit should shine actually. Or a little bit of ground. Actually is on. Low voltage. Okay, the on-off is working. I possibly have the LEDs round the wrong way. I do have the LEDs round the wrong way. Because oh, I'm a doofus. I am an absolute doofus. I put the LEDs in the wrong way round. The arrow needs to point that way. Oh, I'm a doofus. Okay, so I got the component off. I damaged the yellow one. Now that arrow has to point that way. Towards the 15 ohm resistor. Like so. So let's clean up those pads. I'll fix the design to show the correct orientation for the diodes. The pads were from Ultra Librarian and they unfortunately have an error on them. Not much I can do about it. Now that one's the green LED. I'll have to put a new yellow. The yellow one got broken, unfortunately. This one appears to be okay. Alright. Time we resolder this component back on. So. Helps with bonds. And we'll use a little bit of hot air to fix it up. Time we got to, and what I might do is use a little bit of solder paste. Okay. Give that a quick clean in the ultrasonic wash. Okay, so this was the LED flasher project. It's the first in the series of the Funway and SME. It has been sponsored by PCBWay. They are sponsoring the series. This project will be available for purchase from their projects site, including with components. And all you need to do is just watch this video to learn how to assemble the circuit and also go through the circuit description. So I'm now going to get on with the next project in the series, the Ding Dong Doorbell. That should be coming out in the next couple of weeks. If you want to be awesome, please sign up to my Patreon. I unfortunately lost my job 3 months ago and it has unfortunately slowed down the rate of my videos. So if you can sign up and become a patron, you will help support me creating these videos and to be able to get the parts needed to be able to make the circuits and demonstrate them. So good thanks from the folks at PCBWay for sponsoring and helping my channel. And I will see you in the next one. Bye for now.